team alt+f4 from the University of Peradeniya, and today we're introducing Margo, an autonomous supply chain disruption agent designed for this hackathon. So the critical B2B problem that we've identified is that every single day, global supply chains are interrupted by port strikes, extreme weather, and geopolitical events. When a disruption like this happens, supply chain managers are usually forced to manually cross-reference news updates against their ERP and freight systems. And oftentimes, what happens is that this manual investigation can take hours and days to sort of like identify the event and then look for manual rerouting of shipping routes. So while this investigation takes such a time, the cost of the delays can compound, and what can sometimes happen is that even a single delayed shipment can stop production lines and cost a company far more than the price of a simple reroute. So what our team aims to do is that the team aims to sort of like automate this process and reduce the cost of these delays compounding. So the way that our workflow is going to be is that Marga is going to compress hours of this like manual scramble to to a response that can be calculated in a few minutes. So the way our solution works is that it's not a rigid linear script. It operates on a continuous perceive, reason, and act loop. The agent will dynamically decide its next tool call based entirely on what the previous tool call returned. So here's how the reasoning loop works. So firstly, the agent will monitor maritime, weather, and news feeds, looking for the events that might affect the supply chain. Secondly, it will look at the exposed goods to these events. For example, if there are certain stocks in our inventory that will be affected by this sort of event, it will flag those. Thirdly, what happens is that it generates alternatives by querying freight forwarding API. So it will look for alternatives for the same route. It could be like rail, yeah, or like alternative like port alternatives. Fourthly, what it does is it reasons through all of these options, looks at all the trade-offs, and calculates what's the best option, what's the cheapest option that we can go for. And afterwards, what it does is it is gonna give this to the human in the loop. Because at the end of the day, this is, even though this is gonna be automated for the most part, there has to be a human in the loop to sort of like verify the action that we're gonna go ahead with. We've also built in robust error handling and robust error and like ambiguity handling, because in certain instances, because of the nature of this business, even a few errors can cost a lot to the users. So we made sure that we built in a lot of like error handlings and ambiguity handling for edge cases, so that in the very worst case, that even if the agent is not sure what to do, it is going to like revert back to like the human. So the way our technical architecture is going to look like is that we're building a modular failure tolerant architecture. The our data flow begins with a monitoring agent reading external feeds, where it tracks maritime tracking and weather APIs. When an anomaly occurs, it crosses the relevance threshold, an orchestrator LLM conditionally triggers our internal APIs. During phase 2, the most important things that we're looking to put is that we're gonna integrate the APIs which will affect like we will be using the ERP system API, which will look into the amount of like stocks that are affected. We will also use a freight forwarding API that will return alternative routing options. And we will also use a Slack API to manage the communication layer, where users can get these sort of events as like get these sorts of events as Slack notifications. But that is just an additional thing, because after the AI agent is completed, you can modularly use it with any other apps as well. It doesn't have to like depend on Slack. So this is what I mentioned previously, that there will always be a human in the loop. So this is an example of the disruption alert that will be given by the user, given to the user. It will show the how long the shipment is going to be delayed. It shows the risk of the stock out as well, and it recommends alternative air routes, and it shows you how much you can like save by looking at this like alternative route. And the manager can then decide to approve, reject, redirect, or request more information. As you can see, we've shown the differences here about how much you can save by switching over to our agent workflow over rather than just simply depending on the manual or traditional ways, because oftentimes the manager notices these disruptions a bit late, and because of that, even if like if it's delayed by a few hours or days, it can like cost the company a lot. Whereas on our side, the agent monitors real-time feeds and you get a solution as fast as possible, way faster than if a manual human was in the loop. So the industries that can benefit the most from this, who can save a lot, are the manufacturing industries, pharmaceutical industries, retail supply chains, automotive suppliers, and electronics distributors. Because we can save, we can save a lot of hours, and because of that, you can increase the ROI that you get from these systems by around 5 to 10 times. Thank you for your time.